All right, a boy on a toboggan is sliding down a snow-covered hillside. The boy and the toboggan together have a mass of 50 kilograms and the slope is at an angle of 30 degrees to the horizontal. Find the boy's acceleration if there is a frictional force of 64 newtons. So again, where it says acceleration, that means we are looking for an F-net parallel. We need to find that out. Again, let's draw our free body diagram to kind of start ourselves off here. Did I hit record? Is it going?
Yeah.
Yeah, okay.
Wow, it's be embarrassing when you look back at these videos and
It's okay. I can handle it. Okay, so let's write in our direction of motion. So this is falling down, or sliding down. So direction of motion. So if our direction of motion is going that way, then our FF needs to be in the opposing direction. We also have our FN is perpendicular to the surface. And then FG goes directly down. Again, we need to break our FG into its two components. So my FG perpendicular and my FG parallel. And this theta here, it gave me an angle of 30 degrees. So this is 30 degrees. I'm also going to now draw my FG parallel directly on my free body diagram. So there's my FG parallel. Okay. So let's start with just what is our formula for F-net parallel. So this is step one. F-net parallel is equal to FG parallel minus FF. Well, I was told my FF is 64 newtons. And I can find F-net parallel here. Oh no, I can't, not yet. I can find my FG parallel by using trig. So sometimes I just start with my original equation that I know I need to use, and I just kind of leave a note to myself of how I'm going to figure out each part of it. So then it's just a little bit more organized, and I kind of have a game plan of how I'm going to do the question. So I'm going to use trig with this triangle here. So this is like step two. So I have my FG. Here's my FG perpendicular and my FG parallel. And this is 30 degrees. Well, I still need to find my FG. So my FG is equal to M times G. So FG is equal to 50 kilograms times by 9.81 meters per second squared. So FG, you should get 490.5 newtons. So now if I'm going to solve for my parallel, that is opposite to the angle over hypotenuse. So I have my sine of 30 degrees is equal to FG parallel divided by 490.5 newtons. You can cross multiply to solve for FG parallel.
Okay, if you're tired of them, I'll take them, but otherwise we still have a few minutes.
Oh, well, I'll finish this example.
Yes.
Jessica, would you mind getting the door, please?
Yeah. So when you put that into your calculator, you get 245.25 newtons. So this is our FG parallel. So now I just solve for FG parallel and I have FF. So, excuse me, hold on, just wait, please, I'm in the middle of. So now I can go back and use my FG, or my FNet. Okay, just wait, yeah. Alright, so what step am I on? So it was like, this was 2, and this is step 3. Now I can move on to step 4, where I go back to my original equation. My original equation is FNet parallel is equal to FG parallel minus FNet. So now I can plug that in. FNet parallel is equal to 245.25 newtons minus 64 newtons. So FNet parallel is equal to 181.25 newtons. But what I'm actually looking for is my acceleration. So A is equal to FNet parallel divided by M. A is equal to 181.25 newtons divided by 50 kilograms. So A is equal to 3.625 meters per second squared. In sig digs, that needs to be 3.6 meters per second squared. And this is just going down incline. So after this, you can now do inclined planes practice problems 1 and 2. I want you to do these first. This should be done after this video or after this lesson. Depending on how things go, I might move on to the next thing. So people that are here, check for another video. There's one following. And instructions will be at the end of that video. And yeah, so that's that.